We've seen several of these fractions before, but this particular section really focuses on fractions. So let's go one problem at a time and knock these out. Here we go. 35 over 40. We need to simplify this. When we simplify or reduce it, we're looking for the greatest common factor, the biggest number that both of these are divisible by. So if you think about it, and again, if you're struggling with your times tables, it's going to impact this. So I highly recommend that you polish your times tables, make sure you work hard on them. If you don't see it, both of these are divisible by 5. And when you divide both of those by 5, the greatest common factor, that's going to give you 7 over 8, and that's it. Next one, 21 over 24. You're looking for a number that both of these are divisible by, both divisible by. So what is a number that is shared, common, that they're both divisible by? That can be a factor of them. The answer for this one would be 3. And so when I divide 21 by 3, I get a 7. And then 24 by 3, I get an 8. It just so happens to also be 7/8. That's just a coincidence. Okay. Now, again, right now I can't really do much for you if you don't have your times tables, but what I can do is recommend that you do a Google search for times tables, pull up an image of it, and it'll have everything. The good ones will have 0 or 1 all the way up to 12, maybe even 13. The 0 times anything, of course, is 0, but generally 1, the 1's all the way up to the 13 times 13. Another way to do it is to download a multiplication tables app, and that can help you as well. What you need to do, though, is at some point memorize them. All right, 35 over 45. What is a number, a factor that they share, that's in common, that they're both divisible by? Well, 5 would be my initial, what am I getting? We got the same, almost the same problem. These aren't very varied on mine. Hopefully you guys are getting something that's a little bit more broad and hitting more numbers, but there it is. Okay. Any questions about yours? Any problems that you're not getting? Okay, next. 40 over 72. Same concept. What is a number that they are both divisible by? Now, what's a little bit difficult about this is that for a lot of people, they might not see it. They might not see that it is 8. And if you don't see that it's 8, there is still a way to get to the answer of 5 over 9. Let's say, for example, that you happen to not realize that 8 is the biggest, the greatest common number that 40 and 72 are divisible by. Then, let's say that in your mind you can only think of 2. That's okay. Divide them both by 2 and see what happens. 40 divided by 2 is 20. 72 divided by 2 is 36. You still have to have some kind of a handle on your times tables to be able to do this without a calculator. And ideally, you're able to. Now notice, these aren't the same because you should always ask yourself, can I reduce this further? Is there something else that these are both divisible by? And maybe you don't realize it's maybe a 4 right now. And if you don't see that it's a 4 and you just see that it's maybe a 2 still, that's fine. Keep going with it. 20 divided by 2 is 10. 36 divided by 2 is 18. Again, you still have to have a handle on division. Ask yourself again before you shut things down and box this up, are 10 and 18 numbers that share something that they're both divisible by? And yes, another 2 will work. And so when I do that, then I finally get to the same answer above. Now, why is this a little bit more optimal? Because it's in one step. But, of course, a lot of students, on the other hand, may not see this. And so worst case, you have to take the long route to get to the answer. As long as you're constantly checking, you should be able to get to the same answer. Again, it is going to hinge upon your ability to have some mastery over your times tables. Okay, next. 4/5. Write it as a decimal. Now, in order to write these as a decimal, you have to have a particular skill that we talked about last class, and I'll just put it over here. A over B is the same as A divided by B is the same as A divided by B. Okay, so this rule, this skill, to know this is very important. Why? Let's take a look here, because 4 over 5 is the same as 4 divided by 5. 4 over 5 is the same as 4 divided by 5. Now, unfortunately, we don't have all the time to go through how to do long division on a fraction, but I will show you all the work. When I divide 4 by 5, I can't do this one, so I'm going to put a decimal point in. That'll allow me to add a 0. Will 5 go into 40 now? Yes, it will, 8 times. Notice, again, the student who has a good handle on times tables probably won't falter here. However, the student who is struggling with times tables will probably have a tough time getting the correct answer. And so, the answer to this, now that I have a remainder of 0, the answer is 0.8. So 4/5 as a decimal is 0.8. If you're able to do that without a calculator, you're moving in the right direction. If you're relying on a calculator to do this, for this particular part of the class, it's not ideal. And you might find that when you get to a test and you can't use your calculator, you're going to kind of be in a position where you won't get these correct. Okay, so work very hard to do these without the aid of a calculator. Number 6, 1/4. So 1 over 4, we know this is the same as 1 divided by 4. So 4 does not go into 1. All right, no problem. So I'm going to put a decimal point in, and that'll allow me to add a 0. Will 4 go into 10? Yes, 2 times. 8, subtract, and that's a 2. Now I'm not done yet. Like the previous problem, I was finished because I got a 0. However, I have a remainder, which means I need to keep going. Add a 0, and then do it again. Will 4 go into 20? Yes, 5 times. Once again, having a good handle on your times tables makes a big difference. Okay, let's do another one, 5/8. So 5 over 8, we can rewrite that as 5 divided by 8. And now, will 8 go into 5? No, so there's the decimal point. Bring in a 0 to see if we can now do it. Will 8 go into 50? Yes, it will, 6 times. 8 times 6 is 48. Subtract. There's a 2. We're not done yet because that's not a remainder of 0, so we'll add a 0 here and keep going. Will 8 go into 20? Yes, 2 times for a 16. Subtract. That leaves us with a 4. Since I don't have a 0 remainder, I'm going to keep going. Add a 0. Will 8 go into 40? Yes, 5 times for a 40. And now that I have a 0 remainder, I know I'm done. This 0.625 would be the decimal equivalent to 5 over 8. Are there any questions about your problem? Yes.
Mine is 10 over 16.
Okay. All right, tell me the setup. What goes inside?
10.
Good. And obviously outside 16. Now, what would be your first step?
To add the extra 0 by
Okay, good. So I'm going to throw a decimal point in here, and then one up here, and then that's going to give me a 0. Okay, now what?
Divide 100 by 16.
Good. 100 divided by 16. So you're asking yourself the question, how many times will 16 go into 100? What do you think?
6 times.
6 times. Very good. So what do you get with that?
98.
90. There's just a small mistake there. Not 98, but 90. Try again.
96.
There you go. Small area with your times tables, but it does kind of make a difference here, and so that should probably solve everything for you. But you were on the right track leading into it, which is great. So I'll just close down this problem. 16 goes into 40, unless you know it.
2 times.
2 times, good job. And leaving you with an 8, and then we're going to bring in a 0. Will 16 go into 80?
Yes.
Yeah. How many times do you think?
5.
Yeah, 5. And it just so happens that our problems are the same answer, just with slightly different numbers. And you can kind of see actually, because this is actually exactly double the 5/8. Double the 5 is a 10, double the 8 is a 16, so they should be the exact same answer anyways. Good. Anybody else? Anything? All right, good. 2 examples there, 2 examples before that. Let's keep going. All right, 5/22, write it as a decimal. Let's go take a look at this one and work that out. Let's put it here, it's fine. I'll just go ahead and write it as the long division, and let's get started with that long division. 22 into 50 would be 2 times, and 44, and then that would be a 6. Bring down 0. 22 goes into 60, not 3 times, only 2 times. So another 44, and that's going to be a 16, right? Bring down a 0 into 160. That one's a little bit large, but it's probably not enough for 8, 7 times. And so that's going to be a 14, 154. And I'm going through this a little bit quickly, but you guys take your time through yours. And of course, if you have a question, let me know. Now I have a 6, bring down a 0. I'm actually back to a 60. So that's going to bring me back to 2, and there's a 44, and here we go doing a loop of what? 60, 160, 60, 160, and it looks like it's just going to do this over and over again. So the way that we would interpret this is it looks like we're going to have 0.2272727. So this 2 is not in the repetition, but from here on, 27, 27, 27, that keeps going, just looking at the way that things are playing out here. So my answer would be that it looks like it's going to be 0.227 with a bar over the part, only the part that repeats itself. The 27, the 27, the 27. So that is why it looks like this would be the correct answer. And let's just check it just to make sure. And it is. Okay, so what's the lesson to take away from here? There's actually 2 lessons in this. Number 1 is you put the bar over only the digits that will repeat. Lesson number 2 is the bar itself. The bar represents shorthanding or shortening up, and so that you don't have to write over and over again the ones that do repeat. Okay? Any questions about your problem? Anybody want me to do yours? You just let me know. Okay? All right, let's keep rolling. Number 9. Okay, we get to some fraction multiplication. And so I've got 3 over 11 times 1 over 5. 3 over 11 times 1 over 5. Now, I'm going to initially start off by discussing fraction multiplication. So I'm going to put it up here as multiplying fractions. Actually, I'm going to put it right down here. Multiplying fractions. I'll do it this way. Okay? So when we multiply fractions, the very first step that we take is we look for cross or diagonal cancellation or simplification. Whatever way you want to look at it. And I'll discuss this when it comes up, when it presents itself. If this is not needed, because this may or may not occur, then what you will do next is you will multiply across. So if I have A over B times C over D, it would be A times C, B times D as my multiplication. That's the general process. So in the event that you have fraction multiplication, unlike fraction addition or subtraction, recall that fraction addition or subtraction, we had to have a common denominator. That was the last lesson. You don't have to have that at all. So in a way, multiplication is significantly easier. Let's take a look at this problem. So I will tell you immediately that there is no diagonal simplification or cancellation that you can do. I'll show you that when we get to one that actually has it. Since this doesn't apply to our problem, we can move forward with multiplying across. 3 times 1, 3. 11 times 5, 55. And that's it. However, just make sure, just for good measure, always check if you can do some final simplifying. And when I say final simplifying, 3 over 55, back up, back up, back up, back up to the very first thing that we did today. This is all simplifying. This is all reducing. If at the end of your multiplication, you can do some reducing by a greatest common factor, then do that. Do 3 and 55 have a greatest common factor that they can both be divided by? No, they can't, so I'm done with this one. Okay? Anybody have questions on their very first multiplication problem? Anything? Okay, number 10. 5 over 7 times 2 over 11. All right, so let's take a look here. First and foremost, I will tell you there is no cross or diagonal cancellation simplification in this problem. Again, when we get to it, I'll show you. Since there's not, let's multiply across. 5 times 2 is 10. 7 times 11 is 77. Now, back up. Step 3, and ask yourself if we can do any of this stuff simplifying by a greatest common factor to 10 over 77. No, they don't have anything in common, so that's it. Questions? Okay. Anybody want me to do yours? All right, let's keep going. Now, looks like they take a quick break to do an addition problem. So 5 over 7 plus 1 over 7. I'm guessing that they wanted to do this because they want to make sure you can see the difference between multiplication and addition. Look, when you're doing addition, the wrong way would be to add and add. 5 plus 1, 6. Yes, you can add the top. But the bottom does not get added. The bottom stays the same so long as it's common. And that goes back to our last lesson. So maybe that's why they threw that in there, to really make sure that you understand that addition is very different from multiplication. As long as you have a common denominator, it stays, and then you can add and do the operation to the top. However, multiplication, multiply top, multiply bottom. And another one, number 12, we can do it. In fact, what I'll do is I'll work backwards here actually. And we've got 1 over 10 plus 7 over 10. And of course, what that ends up being is that ends up being 8 over 10. And of course, if you can, any fraction, simplify. This one is not done because we can simplify. We can divide everything by 2. And so that's going to be a 4 over 5. So if you can simplify, whether you're adding, subtracting, multiplying, do it. Any questions about that? All right. And the same thing with subtraction, just like we mentioned a moment ago. So I've got 15 over 16 minus 11 over 16. I've got a common denominator. So 15 minus 11 is 4. 16, no subtraction, stays 16. Then, like we said, if you can reduce, do it. Divide by, greatest common factor, 4. And so my answer would be 1 over 4 for this problem. I hope that seeing addition and subtraction side by side with multiplication helps you see the difference between how each of those problems is taken care of. All right, so I'm going to skip number 14. You guys get the idea. I'm going to skip number 15 because we just did that. Well, let's do it. Let's get a greatest common denominator and do all that. Let's just go ahead and do it, just to be sure we've got it. Okay. So I've got 1 over 7 plus 1 over 5. Now, if you're adding and subtracting fractions, you always should make sure you have a least common denominator, greatest common factor, least common denominator. And so when we have this, adding and subtracting fractions, we need to make sure they are common. So what is the lowest common number that both of these can become? Well, it's going to be 35. So if I multiply this one by 5 and this one by 5, this one by 7 and this one by 7, then what I'm going to do is I'm going to end up with fractions that both have denominators of 35, which is going to set me up for success and close things down like we did these problems. But remember that you can't do any addition or subtraction unless the denominators are first common the same. All right, so that's going to be 5 over 35 and 7 over 35. And now I can just go ahead and finish. That's going to be 12 over 35. Ask if you can simplify any more. No, I can't, so I'm done. Any questions about your addition problem? Because this one's a little bit tougher due to a common denominator being there. Any questions at all? You guys want me to do yours? Okay, yes, let me know. All right, okay. 16. Not so bad. I mean, let's go ahead and do it. Just so that we have some problems laid out. 1 over 2 plus 1 over 4. What's the lowest common denominator? Well, this 2 can be made into a 4. All we have to do is change this fraction and we're good to go. So that's going to be 2 over 4 plus 1 over 4, which is 3 over 4. Done. Questions about that one? Anything I can help you with on your problem? Please let me know. All right, number 17. 5 over 8 minus 3 over 20. All right, so the way that I look at this one is I'm going to take multiples of 20 until one of them works also with the 8. So ask yourself, well, can 8 become 20? No. But what's the second multiple of 20? The second multiple of 20 is 40. Can an 8 become a 40? Yes, it can. Since 8 can somehow become a 40, then 40 is going to be my lowest common denominator. So 8 times 5 is going to make 40, and now I've got my lowest common denominator. So again, to recap, 20 is the bigger number. I take multiples of it until the other number fits within it. So 20 times 1 is 20. Nope, 8 doesn't fit within it. 20 times 2 is 40. 8 can multiply to make a 40, specifically by 5. And so now I have that. And what I do to the bottom, I also do to the top. So that's going to be 25 over 40 and 6 over 40. Then we can subtract. 25 minus 6 is 9 over 40. Again, always ask, can I simplify? If I can't, then I'm going to just box it. Any questions about that at all? Yes.
I think I did mine. I don't know where I messed up.
All right.
Mine was 7 over 10.
Okay.
Mine is 4 over 15.
Okay. All right. And we have space. So what do you think? What did you think for your lowest common denominator?
30.
You're absolutely right. 30 is the lowest common denominator. Fantastic work. So I'm going to do it this way and put down 30 here. Now, obviously 15 had to multiply by what to make 30?
2.
Good. So what do we do with the 4?
Multiply by 2.
Great. So what do you get over here?
Over where?
Above this
Oh,
30.
8.
Good. Nice job. So our second fraction, the one that kind of set the tone for us, becomes 8 over 30. How about the 10? What does 10 have to multiply by to make 30?
3.
Good. So that tells us what about the 7?
Multiply by 3.
Exactly. So what do you get?
21.
Good. So hopefully we're good there. Now let's go do the subtraction exactly. And what do you get with the subtraction?
Let me do it fast. 3.
That was the small mistake.
Oh wait, okay, I see what I did.
So what is it? Not 3, but...
Negative 3.
Ooh, no.
Wait, how did that be?
It has a 3 in it for sure. Your answer has a 3 in it for sure, but it's not negative 3, and it's not just 3. 21 minus 8. I'm glad you're doing it without a calculator. I'd rather you take longer to do it without a calculator than to get the right answer with one. 21 minus 8.
I don't know what I messed up on.
13.
Oh my gosh. That makes sense.
That's right.
So that'd be 13 over 30.
Exactly. And of course that can't be simplified, so you are indeed done at 13 over 30. Alright, you had it right for most of it. Just small adding and subtracting, no big deal. Alright, so 7 over 8 divided by 8 over 3. This is the first time we've seen division, and so I left a space above the multiplication rules so that I could give you our division step. So when you see division, the very first thing, the first and only thing you're going to do is something a student of mine passed on to me, I don't know, 2, 3, who knows, many years ago. And that's going to be a KCF, so that's keep. So you're going to keep, change, and flip. Let's take a look at what that means. So when you see division, the very first thing that you do is to keep, change, and flip. If that resonates with you, that's great. If not, do it however you want or think about it however you want, just as long as you get the correct answer in the first step. Keep the first fraction the same. Change the division to multiplication and flip the second fraction. That's what that means. Okay, so keep, change, flip means that you keep the first fraction, change division to multiplication, and then flip the second fraction. And it's always the same way every time. So in the event that you see fraction division, that is the process you take. Once you have that, then immediately proceed to your steps for multiplication. Notice how this problem is ready to go just like these two. So now you can simply treat the problem just like multiplication. I will tell you that there's no cross or diagonal cancellation occurring in this problem either. So this is 21 over 64, and there is no simplification that can be done. Okay. Anybody have a problem that I can do? You're number 18. Anything I can help you with? Doing okay? You're getting yours correct? Let me know. I'm happy to do your problem. Okay, 19. 12 over 5 divided by 2. All right, so this is recall last that we've talked about this. And so if I have any number, I can write it as anything over 1, or the other way. So if I have some whole number, I can write it as that over 1, or if I have something over 1, I can go backwards and write it without the 1. Remember this little rule. Why do I say that that's important? Because the first thing that we should do here, since we see this, and you kind of see where I'm going with it, is to rewrite this as 12 over 5 divided by 2 over 1. Why is that so valuable? Well, it's valuable because in the original problem, it's a little bit difficult to see how to keep, change, and flip the second fraction. So if you don't have it written as 2 over 1, or know that you can write the 2 as 2 over 1, then you might have a little bit of trouble keeping, changing, and specifically flipping the second fraction. Any questions about that? Why we wrote 2 as 2 over 1 now? That's why. You guys with me so far? Now, this is the very first problem of the day that we have cross or diagonal cancellation simplification. Let me show you how it works. I want to bring you back to all of this stuff right here for just a moment. Recall that what we did here was figure out if these pairs of numbers in the numerator and denominator had something in common that we could reduce or simplify them by. And what we do with this is we look diagonally to see if we can do the same thing. Unlike these, which are top, bottom, up, down, top, bottom, these we look diagonally to see if we can do the same thing. Now follow along. If I look diagonally with the 12 and the 2, do they have a number that they're both divisible by? Yes. 12 and 2 diagonally can be canceled or simplified by 2. 12 is divisible by 2. What is 12 divided by 2? Well, it's 6. 2 is divisible by 2 as well. What is 2 divided by 2? 1. And that is our first example of cross, diagonal, cancellation, or simplification. However you want to look at it. That's what it is. Everybody got that? So, cross or diagonal simplification is essentially the same skill that you know what to do, except instead of looking top, bottom, you're looking across, diagonally, to do this skill. And again, now I'm going to come back to the first problem we did. See 3 and 5? Nothing. 1 and 11? Nothing. 5 and 11? Nothing. 2 and 7? Nothing. But 12 and 2? Yes. Okay? So once you've done that, check the other direction. 5 and 1, 1 and 5. Are 1 and 5, do they have anything that they're both divisible by? No, you can't. So what I'm going to do is I'm going to rewrite this problem just so that it's easier for me to see what's left over after the diagonal, cross, cancellation, simplification. Now, just multiply. Finish out the problem. 6 times 1 is 6, 5 times 1 is 5, and I'm done. Does that make sense? Okay, so this is the first problem that does everything. This is a very good example of division. Division using this little rule. Keep, change, flip. Cross diagonal cancellation. Multiplication skills. This problem literally does everything, except for maybe negative signs and things like that, but that's not that big of a deal. All right, I'm going to leave this here and start working backwards this way. That way you guys always can see that simplification is always part of the conversation. All right, 9 over 14 divided by 4 over 7. So let's look here. I've got a division problem. When I have a division problem, my immediate step, the thing that needs to be immediately done, is keep, change, flip in that order. Keep, change, and flip in that order. Then that immediately sets me up for multiplication. With multiplication, the very first thing we check is cross or diagonal cancellation. Let's look at this. 9 and 4. Do we have anything between 9 and 4 that we can simplify by? No, we don't. So that has nothing. However, 7 and 14. Do those have things? Yes, they're both divisible by 7. Once again, times tables, times tables. So I know that 7 and 14 are both divisible by 7. So I'm going to divide them by 7. What's 7 divided by 7? 1. What's 14 divided by 7? 2. And once I've done all of the cross or diagonal cancellation and simplification that I can possibly do, then I will rewrite the problem, because it's a lot easier to work with 9 over 2 times 1 over 4 than to try to look at things that are crossed out and make sense of that. So it doesn't take very long to rewrite your problem, but it makes finishing it out a lot easier. Then simply multiply across and complete the steps that we're used to from multiplying. 9 times 1 is 9, 2 times 4 is 8, and of course always ask, can I simplify that? No, I can't, I'm done. Any questions about your number, 20? Anybody want me to do yours? Anything? Okay. 21. 1 over 27 divided by 1 over 9. Okay? Let's get going. Keep, change, and flip. Now we have a multiplication problem. Step 1, check for cross or diagonal cancellation. 1s, nope, nothing to do there. 9 and 27, yes, they're both divisible by 9. 9 divided by 9, 1. 27 divided by 9, 3. And so I've now simplified, canceled diagonally. Rewrite the problem because it's a lot easier to work with 1 over 3 times 1 over 1 than to look at this sort of a mess and finish it out. 1 times 1 is 1, 3 times 1 is 3, and we're done. Got it? Questions? Let me know if you want me to do your 21. Happy to help you. All right. Now I will tell you, you guys don't have to worry about 22 in this particular class, so I'm not going to stress that. 23, no. We already did stuff like 24 with order of operations. 25 we did, 26. You don't have to, you could actually do this. In fact, let's do 26 just to close this out. So let's back up. I'm not going to stress you guys out to complete stuff like 22 and 23. They're not tough, but frankly, for this particular class, we don't need them. 23, don't worry about it. But 24, you could do. We've done stuff like this. I'm not going to do it, but you could do it. So do that. 25 you can do, and I'm going to do 26 right now just because it's a nice, complete problem to make sure you guys refresh that. All right, so this is the last problem we'll do for the day. Let me clear this space and we'll finish this one. All right. And surprisingly, this is actually quite easy compared to some of the stuff you guys have done. All right, so here it is, last problem of the day. Let's close this out. And let's talk about what we should do first. We should attack this fraction. Let's attack this fraction top, separate from bottom, then together. Once we do that, we'll do everything else. So I'm going to leave the 12 alone, leave the divided alone, leave the minus negative 5 alone. I'm going to leave all that alone as I attack the fraction. 2 squared is 4. 9 minus 7 is 2. And you can already see this is starting to get pretty easy looking. Again, like I said, I am not going to do anything until that fraction is fully complete. 4 divided by 2 is 2. And now it's starting to look a little bit better. Okay? Now, let's look at this problem. Order of operations. What comes first? Division or addition, subtraction? Division. This comes first. So we address this, and now we do the division before any kind of addition, subtraction. 12 divided by 2 is 6, then minus the negative 5. And we're almost done. Okay? Now recall that when we see a minus, minus, we know that it becomes a plus 5, and so 6 plus 5 is 11. Done. Any questions about your 26? Want me to do yours? Any issues? Things I can help you with? Let me know. All right.